Hi, I am Rick Bonney, Director Emeritus of the Public Engagement and Science Program at the Cornell Lab of Ornithology. This presentation is part of a 10-module training program on developing and implementing citizen science projects for which scientists collaborate with members of the public to address real-world problems. The goal for this program is to introduce fundamental concepts of citizen science in U.S. federal land management agencies, which often use citizen science to manage resources and to engage the public in agency missions. This program was developed by several partners, including staff from the U.S. Forest Service, the National Park Service, the U.S. Fish and Wildlife Service, the Bureau of Land Management, and Schoodic Institute at Acadia National Park. This is the fourth module in our 10-module series. Module 3 discussed setting obtainable goals and measurable objectives for your project. This presentation has two goals to help you achieve your scientific and resource management objectives on parks, forests, grasslands, refuges, or similar lands and waters. The first goal is to discuss building a staff team to design and carry out your project. The second goal is to discuss identifying your project audience, that is, the group or groups of volunteers who will participate. This presentation fits within our 10-part series here. 3 takeaways for this module are that citizen science projects are best served by, first, developing an interdisciplinary team, second, matching project type with audience, and third, developing a clear understanding of the audience or group of participants with whom you wish to work. Let's talk about building the project team. Visioning, designing, implementing, and evaluating a citizen science project can be a big job, and pulling it off requires an interdisciplinary team. Few people have the knowledge and expertise to fill all the needed roles, which may be as varied as scientist, education or communication specialist, volunteer coordinator, technologist, and evaluator. Assembling a team early in the design process is critical to success. The team can work together to refine the research question or questions, evaluate whether existing protocols can be used to collect data, design new protocols if necessary, write clear instructions, test protocols and instructions, design data forms and other project supports, recruit volunteers, collate and analyze data, evaluate success, and more. For community-based projects, the team must include members of the community who can represent the community's needs and interests from the beginning of project conceptualization, and in many cases, who can drive the project. Let's take a closer look at some of the roles and responsibilities that need to be filled by qualified people to ensure a project's successful design, implementation, and use. Lest the list seem daunting, know that roles sometimes can be filled by partners, a topic that we'll discuss in Module 5. Also, teams can be smaller for projects that are using pre-existing projects or platforms to develop data collection efforts to meet their specific needs, which we will discuss in Module 7. Research Scientist Resource Manager. Every project requires a leader who is knowledgeable and excited about the research or monitoring that the project conducts. This individual can identify the questions most useful for a project to address and can help to determine the information that volunteers will collect. The research scientist or resource manager also can assess whether the project is providing data and information that will inform land management decisions or answer critical resource questions. This person must be a team player who recognizes and is respectful of the many different areas of expertise that are required to develop and execute a project. Consider Alabama Water Watch, a project of the Alabama Extension Service, which operates a network of water quality monitors across Alabama. The U.S. Forest Service has established a partnership with Alabama Water Watch to monitor water quality across the 4 Alabama national forests. The Forest Service lead for this project is Estella Smith, who is the soil scientist for national forests in Alabama. She has diverse experience gained through many years of work for both the Forest Service and the Natural Resources Conservation Service. Educator. Every project team requires an individual who can clearly communicate the project's aims and desired outcomes and can prepare project support materials. When a people specialist co-leads a project, they can make sure that project tasks are clear and easy to follow, that recruited participants have appropriate skills, that relationships with partners are maintained and participants are nurtured, and that project results are shared widely. Educators also can manage participant feedback to continuously improve the project so that it appeals to volunteers on an ongoing basis. The Alabama Water Watch Forest Service Partnership is co-led by Mona Dominguez, who is the Alabama Water Watch Overall Program Director. For this partnership, Mona coordinates Alabama Water Watch activities, develops training materials, and facilitates workshops. Her academic background in anthropology, environmental studies, and community planning, along with nearly 20 years of experience working in environmental education, helped her gain many of the skills required to lead this project. Volunteer Coordinator. A key position for large or lengthy projects is a volunteer coordinator who recruits and communicates with volunteers, manages their schedules and training, updates volunteer resources and information on the project website, and recommends volunteers for awards or other recognitions. This position may be filled by an agency staff member or by someone at a partner organization. The Alabama Water Watch Volunteer Coordinator is Sydney Smith Zinner. Sydney started with Alabama Water Watch as a volunteer water monitor, then became a volunteer trainer, and now works full-time as the volunteer coordinator. Her experience as a volunteer gave her a unique perspective and helped her understand how to effectively coordinate project volunteers, and her BS in environmental science provided an overall understanding of the need for water monitoring. Technologists. Unless you are using a pre-existing project or framework to collect and summarize data, various technology specialists may be required on the team. For example, if you are developing a customized app or using a program such as ArcGIS Online, you may need the services of a GIS specialist who can advise on how to collect spatial data in a way that meshes with existing agency databases. A data manager also may be necessary to enter and upload data into a usable format. The technologist for the Alabama Water Watch Partnership is Sergio Ruiz Cordova, who developed and manages the Water Watch database and website. He currently provides technical expertise for selecting monitoring methods and developing the program's quality assurance plan. Sergio joined Water Watch in 1993 and gained technology skills through his MS in aquatic ecology. Communication or outreach specialists or public affairs officers get the word out about a citizen science project to enlist engaged and enthusiastic volunteers and to promote the results of a successful project. This position could be filled by a staff member from an agency or a partner organization who should be well-versed in a project's talking points and sensitive to potential misinterpretations of issues covered in the research. For Alabama Water Watch, the communications coordinator is Rachel McGuire. She manages outreach, marketing, and communications and helps with workshop training. Rachel's degrees, a BS in fisheries, wildlife, and conservation biology, and an MS in wildlife science, prepared her well for this position. Evaluators. An often overlooked member of a project team is the evaluator, who is critical not only to determine whether a project has met its goals, but also to help the team develop goals and measurable objectives early in the project and then stay on track to meet them. Few agency projects have dedicated evaluators, but often a team member has the skills necessary to conduct an evaluation, even if informally. For Alabama Water Watch, evaluation is conducted by project leader Mona Dominguez. This list of personnel might already seem long, but a few other positions may be needed to execute a successful project. Team leaders. Some projects have team leaders who instruct and accompany volunteers in the field. For example, in citizen science projects involving youth, local science teachers often lead and assist students in collecting data, A team leader also could be a staff member from an agency or a partner organization. Partnership coordinators or grants and agreement specialists. Some projects, such as those that develop formal partnerships, should have a coordinator who interacts with partners and the project leader and who understands how to develop partnerships. A skill set in grants and agreements will help to codify partnerships and make it possible to share funds and resources among federal and non-federal groups. This individual also can advise on negotiating the terms of contracts, agreements, and grants, and should be knowledgeable about policy requirements. Finally, some citizen science approaches call for partnering closely with communities. This requires additional skills in which scientists often are not trained, and working relationships that even educators and visitor services staff may be challenged to facilitate. Identifying, hiring, or partnering with individuals who can focus on the process of building and maintaining collaborations with community partners is essential for such projects. Module 5 focuses on expanding your project team still further by working with external stakeholders and partners. But before we go there, let's spend some time considering the potential participants for your project, who in many ways are the most important members of your team. The kinds of participants that you'll engage in your project depend in large part on the type of project that you are developing. Let's review the different types of citizen science and how they can define project participants. In Module 1, we discussed 3 types of citizen science: data collection projects, data processing projects, and community projects. We pointed out that both data collection and data processing projects are sometimes called contributory projects because participants contribute or process data to answer a question designed by scientists. And we mentioned that community projects are sometimes called co-created projects because participants work with scientists and land managers to develop and carry out a project. Data collection projects typically define an issue or question that can be addressed or answered only through large amounts of data collected over a long period of time and across a large geographic area. For example, they may involve determining the abundance and distribution of certain plants or animals in a specific geographic location, documenting phenology, that is, the timing of events in nature, or collecting weather or water quality data across the landscape. In some projects, participants not only collect data but are involved in defining or helping to define a research question or issue, analyzing data to address the question or issue, and/or disseminating information about project results. Data collection projects are the most common type of project developed by federal agencies, as you will see in the example projects highlighted throughout this series. Data processing projects typically involve participants in identifying or classifying online images. For example, they may involve classifying photos taken by wildlife cams, classifying photos taken through remote sensing, or digitizing written data records. Data processing projects are less commonly developed by federal agencies, but are a type of project well worth considering. Most agencies probably have considerable banks of data that could be processed through volunteer assistance. In addition, data processing projects can engage a very different type of participant than data collection projects. People who are less able to go into the field to collect data, for example, or people who would like to engage with a project at varied hours of the day or night. In community or co-created projects, participants work together with scientists and land managers in many or even all phases of project development. Often such projects originate with a specific community that has a concern about the local environment. For example, many community projects are focused on air quality, water quality, or concerns about perceived changes in the abundance of local resources. Like data processing projects, community-based projects also are not common in the portfolio of agency-based citizen science. They are well worth considering but involve an even greater degree of project planning. Understanding how to work with communities to help their members address local environmental concerns without prescribing what communities should do is extremely important. Let's look more closely at defining and understanding the audiences for different types of projects, with a caveat. In practice, these types of projects are not mutually exclusive. A blurring often occurs among and between them, and many practices for identifying and working with audiences are appropriate and even necessary across project types. Many project developers consider the audience for data collection projects to be the general public. Of course, there is no general public. Many different publics exist. They have varying degrees of interests and motivations regarding any particular topic, and they have varying degrees of ability to collect data about that topic. For instance, the segment of the public commonly called birdwatchers or birders includes individuals ranging from beginning or backyard birders to individuals who travel widely in search of birds and may have ornithological expertise on par with professional scientists. Therefore, any project focused on collecting data about birds would need to match the needs for data collection, whether simple or complex, to specific birdwatching audiences, and not simply assume that any birdwatcher would be interested in or able to collect any kind of bird data. The same is true for people who like to fish. Consider Engaging Angler Scientists, which is run by Trout Unlimited in collaboration with the U.S. Forest Service in several national forests throughout the U.S. For example, in North Carolina and Tennessee, volunteers have assessed the impacts of road infrastructure on fish passage and sediment pollution in cold water streams, and the data have been used to prioritize management actions, such as the replacement of culverts with fish-friendly structures to minimize these impacts. In Michigan and Pennsylvania, anglers have conducted spawning surveys, identifying key habitats for reproduction of cold water fish. While many individuals like to fish, only a certain type of individual would likely be interested in gathering the types of information that scientists wanted to collect for this project. Therefore, in each forest, project designers consulted with local anglers, fishing guides, and other people who rely on the rivers for their livelihoods. These individuals are able to serve as champions for the project, helping to identify anglers who might be interested in collecting data, and they even help to design surveys so that their methods would be of interest to local anglers. They also identified focal areas for the surveys. Through this program development strategy, the project developers gained a deep understanding of the project audience and how to work with its members. Many project developers also consider the audience for data processing projects to be the general public. In this case, the concept has some legitimacy because the individuals willing to process and manage data usually do so from the comfort of their own computer and may have different motivations to participate than individuals in data collection projects. Many data processing projects are built on the excellent platform Zooniverse, which brings its own audience of individuals willing to participate in data tagging and classification. Data processing projects are ripe for development by agencies. Those that are built on Zooniverse often require less funding and management than full-on data collection projects because of all the support that Zooniverse provides, and most agencies have a lot of data in need of tagging or processing. The Bureau of Land Management's Desert Tortoise Monitoring Project is an agency-based data collection and data processing project that engages participants in studying the tortoise population in Santa Rosa and San Jacinto Mountains National Monument by using a two-pronged approach. The data collection prong involves volunteers who conduct field surveys off-trail with BLM staff looking for signs of tortoises, such as scat, burrows, carcasses, and live individuals. They also record information on habitat conditions, including the presence of invasive species. In addition, these volunteers monitor trail cams in the tortoise's habitat to make sure that the cams are functioning properly and to collect the camera's memory cards. For the data processing prong, volunteers review the trail cam footage to observe tortoise behavior near burrows, such as signs of breeding or predators stealing tortoise eggs from nesting sites. This data processing provides a good option for volunteers who may not be comfortable venturing off-trail or whose schedules conflict with that of the field surveys. Working with communities requires an entirely different approach to thinking about audience. While the audience for a data collection or data processing project may well be a group of people who do not know each other, but who share a common interest, concern, or hobby, community projects generally focus on a group of individuals who have many common interests and concerns and may know each other to some degree. To work with the community, you'll need to learn what motivates its members and why individuals might want to get involved in a community-based project. Learn the ages of your prospective volunteers, their degree of expertise, and their access to resources. This information will help you to design training and support to increase volunteer engagement. If you are working with a specific community, examine any assumptions that you might have about its members. For example, tribal communities, students, and self-selected volunteers may have very different worldviews, needs, interests, motivations, and terms of engagement. The ability to listen well is one of the most important skills that you can bring to this exchange. Get to know your project participants, the culture of their community, and the best ways to communicate with them. Avoid assumptions. Listen carefully, respect different ways of contributing to a project, and be open to local needs and preferences. And don't forget to engage the users of the data to be collected. An example of a community-based project is the Tribal Nations Botanical Research Collaborative. This partnership among the U.S. Forest Service, several Arizona tribes, and Northern Arizona University collects information on traditionally used plants that have cultural, medicinal, or economic values important to tribal communities. Volunteers record observations of plants on a specified list using their cell phones, and they analyze the data to shape conservation and land management goals for increased sustainability. The project takes place in the Apache, Sitgreaves, Coconino, Kaibab, and Tonto National Forests. The project started in late 2018, and by the end of 2022, more than 1,200 observers had made more than 4,000 observations of 35 species. This project began with the participants, Arizona-based Indian tribes, who asked the Forest Service to work with them to develop management protocols that conserve identified species as restoration treatments, which are conducted on the 4 Forest Restoration Initiative project area. The project is therefore first enabling 4 Forest Restoration Initiative managers to develop management protocols to ensure long-term sustainability and availability of these resources for tribes. Second, enhancing tribal access to traditionally used plants. And third, providing data to researchers to devise scientifically based management and restoration protocols for these species. Already, this project has collected significant data that are being used in species distribution modeling, and a project-based article has been published in the journal Diversity as part of a special issue on citizen science for biodiversity conservation. One of the strengths exhibited by all the projects discussed in these presentations is the careful attention to identifying and working with participants to ensure project relevance to all volunteers. Thank you for joining me today. The goal of this presentation has been to help you identify the team members who will design and implement your project and to identify your project audience. We hope you'll take away 3 key ideas. First, that citizen science projects are best served by developing an interdisciplinary team. Second, by matching project type with audience. And third, by developing a clear understanding of the audience or group of participants with whom you wish to work. Module 5 focuses on expanding your project team by working with stakeholders and partners. The accompanying Citizen Science Toolkit includes resources to further guide your project design efforts. Have a great day.